All right. Hope you guys are doing good. Let's start with the joke. How do you say bye to a nut? Catch you later. All right. Nice. Out of the way. Solid joke. All right. Let's see what we got here. Now, last time we were doing expansions of 1 plus x to the power of n. Today we're doing further expansions, and instead of now 1 plus x, now we have x plus y. So we have two different terms going on. It's going to make it's going to complicate things a little bit, I'm not going to lie, but it's actually not too bad, and you just kind of have to settle into the pattern, right? Because as we found out, Pascal's triangle, all these expansions, it's just kind of about patterns. So if you can figure out the pattern, if you can wrap your head around it, not too bad. Okay, now what I might get you to do is very similar to what we did before when I said, 1 plus x squared or 1 plus x to the cube, then I got you to expand it the long way. I want to get you guys to try doing the expansion of these ones first, and that's going to help us to form the pattern. So if you're watching this video and if someone's there, pause it for a second and see if you can expand both these the long way by, writing them next to each other and foiling it out, doing the whole rainbows and frownies. And have a go at those. Okay, I'll pause it. Stuff you. All right. So what we're going to do is, what you should have got is this would end up being x squared plus 2xy plus y squared. So we can kind of see we've got the 1, 2, 1 going on here. And if I was to expand this out, hopefully what you should have got is you should have got x cubed plus 3x squared y plus 3xy squared plus y cubed. Okay, that's what it should be, and it should have followed this pattern here. Now, I hope you're kind of seeing a pattern here. I'll explain it a little bit more in depth. But what is the pattern? So if I was looking for x plus y to the power of 4, now the way that it works is your first term kind of goes up one at a time. And then, it's actually, this one goes down. This power goes down, this power goes up. Okay, so the way that I think about it is, well, first of all, I know that my numbers are going to be 1, 4, 6, 4, 1. So I know I'm going to have those. Now it's just going to be my job to find out what happens in between. So I know that I've got these numbers from my Pascal's triangle, but the way it starts is the first term is always going to be x, and it's going to be to the power of, I guess, whatever, 1x to the 4. So if it's to the power of n, it'll be to the power of n. If it's to the power of 4, it'll be power of 4. Now for the next term, right, it's going to be 4 lots of, and it's going to be the x, the first term now is going to have 1 less power, and then now the y's start to go up in power, just y to the power of 1. Okay, and then the next one, plus, it should be plus 6 lots of, and now the x gets raised to the power of 2, right? Because now the powers of x's are going down, and the power of y's are going up. And then for the next one, it'll be plus 4 lots of xy cubed. And then the last one is plus, and it should just be y to the power of 4. Y to the power of 4. Now, hopefully you can see this. I'll do this here so you can see. Maybe I'll highlight it. Okay, x, as it progressively goes down, what do you notice? It goes down by 1 power every single time. Whereas you look at the y's, they go up. Okay, and that's kind of how that works. So if you need to, pause it and take a look there. Make sure you understand and you see where the pattern's coming from. Okay, because that pattern's going to be super helpful when we start applying it to a question. It's like something like this. Okay, it's going to look a little bit gross. Now, notice how it's no longer x and y, but it's two different things. Our equivalent of x, I guess, here is going to be that 2x, and that's going to be the equivalent of our y. Right, so it's just different letters, but we're going to apply it the same way. Now, what they'll do is they'll say, find the independent term or the term in x to the power of -3. Now, before we can even think about answering those questions, what I would do is I would suggest actually doing Pascal's triangle and doing the whole expansion first, expand first. So I'll make a note there. Expand. Okay, so I'm just going to go back up here, and I knew I would need this. So this would be to the power of 4. This would be to the power of 5. So the power of 6 is going to be fairly large. 1, 6, 15, 20, 15, 6, 1. Okay. So I'm going to write that down. 1, 6, 15, 20. Okay. 1, 6, 15, 20. All right. There's 1, 6, 15, 20, 15, 6, 1. Okay. So first things first is my first term. It's going to be 2x, and it's going to be to the power of 6. All right, there's my first term, and there's going to be one lot of that. Now, for the next term, it's going to be 6 lots of, and now I have my 2x, my first term, and now it's going to be, that's going to go down in power. So it's going to be to the power of 5, and now I'm going to have one lot of those y's, which is going to be x to the -2. It's going to be to the power of 1. Okay, and then after 6, it's going to be 15. So it's going to be 15 lots of 2x, and instead of to the power of 5, now we're going to go to the power of 4. And now we're going to have x to the -2 to the power of -2. Oh, what am I saying? To the power of 2. Okay, so you're going to get that. Okay, now we keep going, plus 20, and that'll be to the power of 20 times. See if I can make some room here. This is going to go pretty long. Plus 20 times 2x to the power of 3. And you know what? This will probably be a good time. If you guys are seeing the pattern, pause it here and see if you can complete the pattern. I'm going to keep going in real time, but pause it and let's see if, after a little bit of time, yeah, you guys actually end up doing it correctly. Okay, so it'd be 20 times 2x to the power of 3. Maybe you paused, maybe you didn't, whatever. And then it's going to be multiplied by x to the -2. And now this is also going to be to the power of 3. And keep going for the next one. Plus after 20 is going to be 15. That's your coefficient. And we're going to have 2x to the power of, in this case, 2. And now it's going to have x to the -2 to the power of 4. Keep going. After 15 is 6. 6 times 2x, and now it's just to the power of 1. But now the x minus 2 grows in power, so it'll be to the power of 5. And then plus 1 lot of, and it's just going to be x to the -2 to the power of 6. That's it. And that's our giant expansion. Now, to answer the questions, find the independent term. This essentially means no x's, right? It's just a constant. That's what they're asking. Okay, so to answer for x, I'm actually going to look which term here, and these are all different terms. It's either going to be that term, that term, that term, that term, that term, that term, and that term. Those are my 7 different terms, and I'm looking for the one that's independent. That means there's no x's, or in other words, it's a constant. There's no variable. So far, they all have x's, but if I look here, maybe if I draw on here, it'll be might be a little bit gross, but this one would be x to the power of 6, because it's just 2x to the power of 6. So I'm going to get some sort of number, 2 to the power of 6, and then x to the power of 6. If I look here, I have x to the power of 5 times x to the power of -2. That's actually going to be x to the power of 3. This one here, I'm going to have x to the power of 4 to the power of x to the power of -4. That's going to be x to the 0. Right? And so that there, this term here is the one that's looking like my constant term. Okay, so I'm just going to stop there and I'm going to actually answer it. It's going to be 15 times 2x to the 4 times x to the negative 2 to the power of 2. All right, so this would be 15 times 2 to the power of 4 is 2x to the power of 4, sorry, is 16x4. And then this would be multiplied by x to the negative 4. Now again, let's just clean that up. It's just going to be 15 times 16 x to the 0. And whatever 15 times 16 is, I don't have my calculator on me. Oh boy, right when I need it. 15 times 16, that there, that's going to be your independent term. Okay, now the term in x to the negative 3 is going to be the one that I guess gives us a term of negative 3. Okay, so x negative 3. So let's keep going here. If I see here, I've got x to the 3 and then x to the negative 6. So x to the 3 times x to the negative 6. Surprise, surprise, that becomes x to the negative 3. That's our term. So in other words, you can say that this term here, that becomes our term in x to the negative 3. So it's for part B, we just say it's 22x to the power of 3, x to the negative 2 to the power of 3, and that there is our term. Okay, there's that, those are your answers. Hopefully that wasn't too long of a video. I tried to condense it as short as I could, but hopefully you guys are starting to see the pattern. And do me a favor, there are no shortcuts. Expand everything out and learn to see the pattern and learn to get familiar with it. All right, that's all for today. I'll catch you guys another time. See you later. Bye.